Hi, I'm Erin Udaly, and I am here today to talk to you about matter. I am here at the Roper Mountain Sims Hall of Science, and we're going to talk about matter today. Specifically, we're going to talk about the 3 states of matter. So first, let's talk about solids. When you think about solids, you're talking about a substance where the particles are very close together and they're only just vibrating in place. Now, with a solid, solids keep both their same shape and same volume. So if I move these little ice cubes into this other beaker, they still keep their same shape that they had before, right? They're still the ice cube shape. Now, if I add heat to the solid from my hand, after a second or two, there it goes. Whoa, there goes some ice too. You'll notice that we start getting a different state of matter. This is a liquid. And when we talk about a liquid, we're talking about particles that are moving slightly faster. At this point, they still have a fixed volume. So right now I've got 100 milliliters of water. If I pour it into this flask, carefully and not spill any, there went my little piece of ice, then I still have 100 milliliters in the different container. It has a different shape, but it has the same volume. And if I were to take this liquid, put it in a kettle, and add heat to that, eventually we would boil that water and it would go from a liquid to a gas. And with a gas, we're talking about particles that are moving very quickly. And they have basically no definite volume at all. And they just take the shape of their container. All right, now, right here, I've got something super cool. It is liquid nitrogen. Liquid nitrogen is so cold that it can actually hurt your skin if you touch it. It is negative 320 degrees Fahrenheit. You can see that there's a gas coming off of this. I'm gonna pull out some of the liquid to show you. Okay. All right. So you can see that it is boiling, even though we're just sort of in a normal temperature room. My liquid nitrogen is boiling in that container. The heat from the room is causing it to turn quickly from a liquid to a gas. The particles are speeding up and spreading out, and you can actually see them sort of spreading out with that gas that's coming off. Now, we're gonna see what happens if we take that liquid nitrogen and pour it over a balloon. Now, this is a balloon that we actually added a little bit of water to, and you can kind of see it sloshing around in there. You can hear it sloshing. So there's some liquid water in the balloon, and then we're gonna pour liquid nitrogen over it. What do you think is going to happen to that water? And what do you think is going to happen to the balloon? All right, so think about that. I'm gonna start scooping out some of this liquid nitrogen. And let's sort of see what goes on. Okay, so we've got some changes happening in the shape of the balloon. Let me get some more. And you can hear that liquid nitrogen boiling from the heat from the room and from the heat from being in contact with that balloon. And maybe one more time. Let's see if we can get this to. There we go. Okay. Now, let's sort of take a look at our balloon now. Did the shape change? Yes. And let's try to figure out what happened to our ice in there. I should say our water. It was a liquid, remember? Now it's turned into a solid. It's actually ice in there now. It's kind of stuck to the side, but you can hear it rattling, and you can see it on the bottom. And the reason the shape is changing back is because heat from the room is now going into the balloon, causing the particles to speed up, spread out again. And if we left this at room temperature for a while, all that solid ice, the heat from the room would turn it back into a liquid. It would melt, right? So that's states of matter. Thank you for watching. When you're at home, next time you're looking at ice, think about how it's a solid. You could do some tests on your own. You could see how quickly it melts at room temperature. You could put some ice in water, see how long it lasts there. You could hold it under running water and measure how long it takes to melt in that condition. So those are some interesting things you could do at home. Thank you.